Good evening, everybody, and welcome to this talk that I'll be doing for EXP Expo. My name is Cairo, and today I'll be speaking about using procedural software like Houdini as an artist to speed up your work and to automate processes in the art pipeline. Just a quick disclaimer before I start. This talk does endeavor to cater towards those who have never used Houdini and its interface before, but due to time constraints, this is not necessarily a step-by-step tutorial, although it will serve to be an introduction to that. I will, however, do my best to explain the higher level concepts so that beginners should be able to start to introduce Houdini into their own workflows by the end as well. So, as I said, just to give you a quick bit of background about myself, as I said, my name is Cairo Goodbrand, and I've been an environments artist in the games industry coming up on 3 years now. I try to incorporate a strong focus on world building and storytelling in my work, and I also have a keen interest in the technical side of game art, which is where I first discovered Houdini and all the processes that could be sped up using it. Here you can see some of the titles that I've had the privilege of working on throughout my career, some released and some unannounced. I currently work at Cloud Imperium Games on Star Citizen, which is the first time I got to use Houdini in a production setting. As the open world of Star Citizen is extremely vast, we use Houdini a fair bit for modular asset creation, and it's wonderful as well for your general sci-fi cables, pipes, walls, and also other organic elements such as caves and natural plant formations. So this opportunity, becoming acquainted with Houdini during work, allowed me to bypass my fears of Houdini a little bit and to delve further into the software and see how I could incorporate it into my work for personal work as well. So we have to start with the basic question: what is Houdini? Houdini is a node-based software for the building of procedural systems. To anyone who has not used it before, I like to compare it to something like Substance Designer, because that's where my sort of like procedural journey started out. Only instead of creating and working with textures, you will be working mostly with volumes, point clouds, and geometry at the end, as well as some textures along the way. It allows artists to create multiple iterations and rapidly share workflows with colleagues. I think that this is one of the great things about Houdini. Once you've created a tool, it's there to use forever. It can be shared with people working in the same studio to speed up their tasks as well as your own. And with well-made menus and interfaces, this will make the lives of everyone involved a lot easier, hopefully. So I think it's a non-starter, a no-brainer that teams of artists all using the same tools are going to get a lot more work done and with a more consistent quality bar and art direction than artists working individually trying to make something using slow, outdated processes. What's more is then other artists can also come in and edit the tool for their own needs, and at the end of the day, you have a communal tool that best serves the needs of the project and the team. Once again, drawing from the substance equivalency, HDAs or Houdini digital assets can be created with options, parameters, and sliders so that you can tweak the tool to do exactly as you would like. So you can create HDAs inside Houdini and then bring them into your game engine of choice. For example, today we're going to be using Unreal for our HDA. And then this results in an integrated tool that can be used inside the engine without worrying about any of the back-end stuff. Houdini has been used in multiple AAA titles, and it's now also filtering down to smaller studios, which we'll get into in a bit. But the most common tools that have been created with Houdini and will continue to be created with it include modular asset creation, such as buildings, rooms, structures, even entire cities. Destruction for that same thing, for all of those elements that we've created, and also the physics properties and those meshes, terrain, texturing, VFX such as particles and emitters, and also volumetrics. Some of the most powerful tools in Houdini involve its simulation capabilities, anything from alembic water simulations to VDB smoke sims. The possibilities with Houdini really are endless. I'm going to quickly talk through some of the more impressive Houdini use cases inside games that I've seen in recent years. The first one that we have over here is this room maker made by Magnus Larsson over at Neon Giant when working on the Ascent. I thought this was a really neat tool to use and to show off because, as you can see, it takes primitives from inside Unreal, such as rectangles and cubes, and it turns them into rooms based on certain parameters that the artists have set. You are then able to sub out different meshes in order to quickly iterate upon your designs. You can also subtract from your primitive shapes with those pink cubes that we saw, and then the room will conform to those alterations, which I think is pretty cool. I believe the Ascent was made entirely up of 4 artists on their team at the helm, so creating Houdini tools like this for speeding up these processes, especially with a small team, is really, really invaluable. Here is a
All
talk
right, I'm here.
from some of the people over at Insomniac Games talking about some of the use cases with Houdini that they used for titles like Spider-Man and the newest Ratchet and Clank game. And they used it for a whole bunch of different things, such as snow placement, vertex painting, imposters, and much more. I can highly recommend the Houdini YouTube channel for more of these sorts of videos with in-depth discussions with devs behind these tools, because it really does provide an insight into what is possible and the sorts of use cases that you'd never even think about. Here we have one final example taken from Cyberpunk 2077, where you can see that the vast majority of the structures inside this building are destructible from weapons. So I would guess that the assets were created by artists through normal means and then run through a Houdini pipeline in order to be broken up into chunks, and so that the destruction simulations can be run in real time in game because they've already been pre-calculated inside Houdini, and as such they're going to be much lighter on performance, much more so than something that is completely dynamic. These are just some of the games that have been made with using Houdini to speed up the pipeline, and there are many others. Houdini has been widely adopted by AAA and even smaller studios in order to further progress development and expand upon the scope and the size of the worlds we build without having to increase development time disproportionately. I think that it's no secret that in our industry things are changing and getting larger and grander every single year. So having tools like this to automate some of the hard work and to allow us to spend more time on the art side of things is nothing but a benefit to us, the artists. So why use Houdini? I think I've already done quite a bit to sing the praises of Houdini, and before we get into the actual software itself, let me continue with some actual points. Houdini aims to make our lives as artists easier. I think this one is rather self-explanatory, and I've probably expanded on it a little bit before, but Houdini tools created for production purposes are going to hopefully increase your productivity and allow you to create many more assets of greater quality than doing things by hand over and over again, dozens, hundreds, even thousands of times. Procedural modeling techniques can be used to maintain a robust construction history and to create complex models such as cityscapes, environments, and more. I've ripped this one straight off the Houdini website, so you're welcome for the free promo, Houdini. But essentially, because of the software being node-based and procedural, our process is run down a chain of events, and we can go back at any point and alter any node of the chain to affect later operations. For example, if an artist comes and says that the tool is not functioning as it should, or that something needs to be changed, instead of having to make the tool again from scratch, one can simply go into the node chain and can tweak the settings of the specific node that is required, and then all changes will be propagated down the line for the output, whatever that is. Iterate quickly and automate tasks. I think this one is also fairly self-explanatory, but if you create a very robust and functional Houdini digital asset, as I said, it will allow you to spend more time on the art side of things. So instead of having to spend a week making an asset only to find out that it's not quite the direction that the project is going in, you can then use your Houdini tools to make a quicker iteration of said asset. And because all the changes will propagate into the tool, you can then make batch changes to multiple assets if the direction changes, for example. create custom functions to match specific studio workflows and pipelines. I think this is an important point to touch upon because not every studio has the same goals and not every studio has the same needs for their tools. Not every studio is going to need destruction in their game, just as not every studio is going to need a sci-fi building generator in their game. If your team is very ZBrush heavy, then you can make tools to accommodate processes for ZBrush and automate the process of, high poly cleanup, for example. You really only need to spend your limited time and effectively your limited budget on what suits you and your specific project as an art team. But enough talking and me singing Houdini's praises. Let's go about making something in Houdini. So today, we're going to be walking through the creation of a simple Lego generator inside Houdini. Essentially, it will take an input mesh. In this case, we're going to be using Megascan's assets and output it with a Lego mesh, which has the correct colors according to the texture based on the Megascan's asset. This isn't anything new or groundbreaking or revolutionary. If you look around on YouTube, there are multiple Houdini Lego generators out there, but I think that it serves as a nice basis for the introduction to the software and also show you that no two artists do things the same way and that there are multiple ways to achieve a desired result. These are some of the assets that I've created using my Houdini Lego generator. This includes the entire terrain, which was created using World Machine and then later converted, the cacti, the grass, and all the various rocks around the scene. Unfortunately, it does not include the cars because that is something a little bit more handmade and something that I wanted to conform a little bit more to the established Lego aesthetic. But in total in the scene, I converted something like 50 different assets that I've created using the Houdini Lego generator. And this is something that I would not have been able to do by hand as it would have been hugely time consuming. This allows me to take away a bit of the less fun stuff out of the work and spend more time on the stuff I actually enjoy. So that is the question, isn't it? How can we go about converting Megascan's assets into equivalent Lego meshes and doing this quickly and efficiently? Doing this by hand is almost impossible because of the nature of the Lego bricks. You would have to go in and manually place these one by one, and that wasn't time that I was willing to waste. So let's get into making our very own Lego generator. Let's get started. As I said, at the beginning of this talk, I'm conscious of the fact that not everyone has opened up Houdini before, so I've done my best to divide these slides into areas of interest. In the yellow box on the left, you have the viewport, where you can preview the results of your node tree. In the red box on the bottom right, we have our node panel so that you can order your different nodes and alternate them. And this is where we'll be sorting out our chain to create the output that we desire. And up on the top right, we have our blue square. We have the details panel, which will give you the specific options and settings for the currently selected node. So that's pretty much the simple gist of the UI interface. So now that we can go into our node setup. We're now going to be working our way from the top to the bottom of the chain so that we can see how we end up with the result. The first thing we are doing here is looking at the input mesh that we have. Now this can be either procedural or non-procedural. The input can be whatever you would like it to be, but in this case I'm going to be using the LOD0 version of a Megascans asset that you can see over here. The second node in our chain, the polyfill, serves to fill in any open gaps in the mesh so that it is watertight. As we're going to be converting that mesh to a volume, and volumes will not work unless the mesh has no holes in it. It doesn't matter if the polyfill function that we're using, doesn't matter if that's an n-gon or how the topology really looks, because we're going to be converting it to a volume. So the point is moot there. The last node that we have over here is a simple transform, but I would argue that is one of the most essential nodes inside the graph, because it's important to remember that we want everything that we input to this tool that we're making to come out as Lego size and scale. Now, why is that important, you might ask? That is because when we are taking our points later on in our graph and converting them into Lego bricks, the calculation and processing time is determined by the size of the mesh, because all of our Lego bricks have to be, they have to have a fixed scale and they have to be the same size. As you can see over here, all of these cylindrical parts of the top of the brick have to be the same size. Otherwise, that illusion of the uniformity and the assembly of the bricks is going to break. It's also a point that the larger the mesh, the more bricks it's going to contain in order to cover the same surface area. Therefore, your mesh will be larger and more intensive computationally. So what we're going to do is we're going to be creating an initial point setup, as you can see from our folder over here. The first thing that we need to do is tell Houdini what texture map we would like to use for the color of our Lego, and this is something that we can parameterize later on for use inside Unreal. This is where the first node on the chain that you can see over here, the attribute from map node, comes in. This is where a texture map can be imported locally, and it will draw the colors of that based off the UVs of our mesh and assign a color to each vertex of the original mesh. If you look at the preview over here, you can see that this isn't as you would expect a albedo map to look. You can see that it's actually assigned one color to each vertex on our mesh, and that's great because we want to simplify the colors quite a bit when we're talking about converting them to Lego. If you look in the details panel, you can see that there is an export attribute over here called CD, and this is used to denote color inside of Houdini. Keep that in mind because there will be a few other attributes we will need to define down the line as well. When we have the points from volume node selected, you can start to see how our Houdini generator is going to be built. The node takes our mesh, converts it to a volume, and then places points inside the volume in a grid-like fashion. This grid determines the density and size of our Lego bricks, so it's important to take a look at the point separation value up over here inside the details panel, which I've set to 0.8 for these calculations. This value is important because we will need to keep it consistent throughout our tool in order to make sure that all the Lego bricks are spaced equally. Next, what we want to do is we want to create a second points from volume node, only this points from volume node is going to have a negative ISO value. So you can see what changing the ISO value does in our node is it's going to start cutting out the outer extremities of all of our points, as you can see in the video. The reason we are doing this is that eventually every point is going to be replaced with a Lego brick, even the points that you can't see on the mesh, our interior faces. We're now going to subtract the difference between our two volumes so that we can remove the points for the interior faces and thus save on the poly count for each asset. And for this, we need to use a wrangle attributes node. So the wrangle attributes node allows us to input code into a V expression, and then this will perform operations and calculations between two groups and their attributes. Don't worry, I know that the sight of code scares artists, but it's going to be okay. This is the only section of code really needed for this presentation. Essentially what happens when a point group is formed is that each point in our volume is assigned a number, and all this code is doing is cycling through each number from 0 all the way up until the last point and searching for points which are close in distance and then removing them. If the wrangle node finds 2 points that are close to each other, it will remove those points, essentially leaving us with an outer shell of points, which is exactly what we want. I'd like to give a quick shout out to Kai Volbeda, who's the real tech wizard here, and he helped me overcome my fear of code, so thanks to him for his help on this. Cool, so now we have our point grid, which is going to be the basis for all of our Lego bricks. So now we need to define color for these. So what we're going to do is we're going to use an attribute transfer node, and we're going to take that directly from the attribute from map node where we defined our texture earlier. And for the other input, we're going to use the result of our attribute wrangle node, which is our outer shell of points. As you can see here, this nicely assigns a color to each point, as you can see, and it even assigns colors for the bottom of the mesh where we had to fill the hole and make it watertight. Now we get to the fun stuff. The copy to points node is really where all the magic happens for this tool. We are providing the node with our points, which we've defined as a group, and now we're going to give it an input mesh to populate at each point. We'll be using the copy to points node extensively throughout the presentation in order to create new groups of geometry and to layer them on top of our base geo. The copy to points input, as seen on the last slide, is this very simple Lego brick which I modeled. As I said before, the inputs for our Houdini tools can either be procedural or non-procedural, but because I wanted a very specific Lego brick size, I chose not to go the procedural route, and I also wanted to control the number of chamfers and bevels on my edges, which was simply faster for me to model than to make procedurally, and that's just a personal balancing act and a matter of preference. You might also notice that I have a second file input over here, which is a lower poly version of the same Lego brick. This is very useful if you wanted to make larger areas of Lego but not have such a high poly count, or even to make LODs later down the line. All you would have to do is plug in the different file into the transform, and then the rest of the calculations will be done as normal. Speaking of that transform, I also have that transform at the end of the line over there, just to make sure that all the Lego bricks fit flush together, and so that I can adjust the pivot points of each brick if I so desire. Just a little bit of extra knowledge you might not have noticed, this attribute blur node, which I didn't touch upon earlier, is in my initial point setup. The attribute that I was blurring over here was the color. And the reason I did this was because taking color from points on a texture can create quite a lot of noise because of how the colors are calculated. And so we can blur it, and then this will allow us to have a less noisy effect on the colors. So I used quite a low value over here just in terms of maintaining the original color variety, because I thought it was quite nice to have the reds and the browns as well as the grays and greens. But having this sort of control is really nice for maintaining a scene and having the noise and the detail in that scene in mind. Now that we have our simple blocks, we want to create slope pieces to supplement those. We need to use the same point grid as earlier so as to keep the location of each slope brick the same as our base bricks, essentially so that they are on top of each other in line and they are not sort of, halfway over to another brick or anything like that. As you can see on the node tree, we have another copy to points node with a different input, and this is just a slope piece that I created. Before our copy to points, this time we have a random selection node in between. I like to view this as similar as the mask random property inside Substance Designer. So very simply, as the name implies, we're going to take a random selection from the original point volume, and based on the ratio that we select, we are going to get either 100% of our original point volume, or whatever percentage we set it to. So you can increase the number of slope bricks procedurally. So I settled on a value of about 5% of the original point volume, and then this allows me to get a nice mix between the two. Now we have our pieces placed, and with the transform node, I am able to move the slope pieces upwards so that the pivots are above the single brick pieces, so that they are placed on top of the other bricks instead of inside them. The problem is that the slope pieces are all facing the same way, and we'd like to introduce some randomness. This is where the attribute randomize node comes into play. If you look at the settings, you can see that we are randomizing based on whatever attribute we set inside the attribute name over here. Here we've set this to N, similarly to how CD represents color. The N stands for normal in this attribute, which is synonymous for the direction in this case. So I've set the node to rotate the slope piece randomly in 90-degree intervals so that we don't have pieces facing any other way besides forward, back, left, or right. It's worth noting that the attribute randomize could also be used for other attributes such as color, orientation, position, and other values as well. The next thing we'd like to work on is layering some different types of Lego bricks on top of our existing ones, but also making sure to handle existing intersections. So we're going to be using the mask by feature node in an upcoming slide to be creating flat pieces on top of what we already have. These won't have the Lego cylinder on top of them, and they can be used for larger flat areas to reduce the visual noise from all the other hundreds of millions of Lego bricks. I eventually decided against creating custom pieces for this. Instead, I just stacked single flatter bricks next to each other, and that seemed to have the effect that I was looking for. As I mentioned, I used the mask by feature node for this. It's very useful for scattering elements and creating masks because we only want to have the flat pieces on top of our mesh and not anywhere else. For this, we're going to be using that node, and what this does is it sort of projects a light, I want to say, quote unquote, top down onto the mesh that we've created, and this is going to create a mask for us that we can later use. If you take a look at the settings here, you can see that it's set to output a combined mask called mask, and the direction is just simply based upon a vector, and with this vector that we provided over here, 1 simply means that it's going to point directly down. It's a very useful note for scattering and creating masks because we want to only have the flat pieces on the top. We want to make this mask that we've created, and we want to use it as a mask for the flat pieces. However, we are now dealing with geometry and not points anymore. So now we need to sort of convert back to points in order to do a copy to points operation like we have before. So now our goal is to separate the geometry based on the mask that we've previously created. In order to do this, we need to create a group for the geometry that is affected by our mask by feature node. So we're going to use this group expression node over here. And I know I say we are going to get away as much as possible from V expressions and code, but we only have one tiny more V expression over here to use, and that is at mask is greater than, and then we have a very low value, which is greater than 0. So essentially, what this is saying to our group expression is isolate all the geometry where the mask value from our mask by feature is greater than 0, essentially. We've defined a group for our mask by features and the name, and that is called mask top. As you can see, so now all the group expression node is doing is saying, look for that geometry covered by the mask by feature, and then create this new group. The split node has a very simple function, and that is to just delete all the geometry which is part of the specified group, and that is going to be the mask top group as we've defined it. So now we have a bunch of geometry which has been separated from our converted mesh, and now we want to use this geometry to convert to a volume and get points inside that volume, similar to what we've previously done. The only thing we need to keep in mind here is for our points from volume node, we need to make sure that the point separation value is exactly the same as for previous nodes, because otherwise our Lego bricks are not going to line up because the points are not lined up on the grid. But we have a problem. We've already gone ahead and we've created slope pieces which are already placed on top of the mesh. Now, if we were to go ahead and we were to create flat pieces on top of those, we're going to have intersections and z-fighting, and it's not going to look at all good in Engine. So to solve this problem, I took the slope pieces that we've previously created, the geometry from the output, and just done a simple poly extrude on them. What this does is I've set this to an inset of -20, and this just extrudes the geometry downwards, so all the way through our converted mesh. What we can then do from that is we can get another points to volume, and now we have a ton of points all inside this mesh. We can use this and the previous attribute wrangle node in order to subtract from these two groups. So here you can see we have the same attribute wrangle as previously, and now we are just subtracting this from our flat pieces, and these are our slope pieces so that we don't get those ugly intersections. So now we have a new point group, same point separation values before, and we're going to use that same attribute wrangles before. Similarly to our first creation when we were working with the single bricks, we use the attribute transfer so that we are able to get the colors from our texture into the point group. And we can also use an attribute blur over here to control the color. This blur value, I believe I increased quite a bit more than the previous because all of the flat pieces would obviously be the same color. So to give the illusion that these were all the same piece, I increased the blur quite a bit so that all of these similar areas had similar colors. Next, we're going to talk about merging, which thankfully and luckily is a very simple process inside Houdini. All it takes is a simple merge tool, which you can see I have two of over here. So this combines our single bricks with our slope bricks to our flat bricks. And then that's pretty much it done for the mesh side of things. But we have a problem, and that's now once we get out of Houdini, how are we going to deal with color inside a game engine like Unity or Unreal? So we have quite a few different colors here. So you could make a Lego master material and it could have an instance color. So then you're going to have to go through and you're going to have to create one new material instance every time you want a different color brick and then assign that to different areas on your mesh. However, the problem with that comes, as you can see in the viewport over here, we have hundreds, if not thousands, of colors over here. Even with the colors blurred slightly, we still have quite a lot of variation. And we want to take out the hard work of the color and the work. So we are going to avoid doing a material instance approach. You could also bake this, although similar properties and problems are going to come up. Even though you would only need technically 1 pixel per color, baking stuff and unwrapping all of this sort of takes all the fun out of it. So the solution that I came up with was, as you can see over here, we're using an attribute promote node. And what this is going to do is it's going to take the color from a point and promote it to the color of the vertex. So we're going to be using vertex colors directly for the color of our Lego. That way we only need 1 material instance per mesh and all the color information is going to be stored within the mesh itself. So inside the engine, this is pretty much my setup. It's quite simple. All you have to do is you take the vertex color, the RGB channels, and that is going to be multiplied by a tint, which I did just to make it a little less bright and a little bit less saturated. And that's pretty much it that goes into the base color. Flat colors, these are the vertex colors viewed directly inside the engine viewport. So you can see that the method works rather well. Because we don't want to spend too much time unwrapping, baking, any of that, not fun stuff, most of the texturing I've done is done with world-aligned textures. So I have fingerprints that are set through this and, general roughness and subsurface intensity. That can all be changed within the editor. So really, the majority of the hard work is done once you've run your meshes through the generator. So we have our tool inside Houdini, so now we want to get it inside Unreal, and this may be the more difficult part of the presentation. So in order to use an HDA inside Unreal, unfortunately the file type by default is not going to be recognized by Unreal, so you have to do a little bit of installations and stuff like that to make sure that everything's running smoothly. So you will need to install Houdini Engine to your game engine of choice. And Side Effects has recently released, fairly recently, free Houdini Engine licenses for Unreal and Unity, so you can import as many HDAs as you please. Yeah, so I think that's a really cool thing. If you've gone through the setup correctly, you should have a Houdini Engine window appear inside your game engine installation, and you will now see that there. It's worth noting that for Unreal Engine 5, which is obviously a newer version of the engine, you will need a daily build for the Houdini installer. So we have quite a few more steps to jump through in terms of getting Houdini to work inside Engine. So Houdini is very big on their licensing and making sure that everything's as it should be when you're running through all of this. So you'll need to make sure that you have a license for both the Houdini Engine and at least a Houdini Apprentice license installed on your machine. This is in order so that you can create a session which is able to run your Houdini digital assets. as I understand it, Houdini is still doing all the calculations and work in the background. It is just needed that all of these licenses to create a session so that can be done. So this is our final HDA inside Unreal Engine. So all you do is you drag that big orange Houdini logo into your scene, and then you can see on the right hand side we have some options over there, and the way that they've integrated this into Unreal is actually quite handy. You can change the geometry input to world outliner input, and then you can simply go into your world outliner and select whatever you'd like to convert for your input geometry. So in this case, I've just selected this Megascans rock, and then it's computed for a few seconds and outspits the generated Lego piece. We do have some Houdini parameters for our HDA. So for example, I can change between the default mesh and a custom mesh. The custom mesh is the one that we're using inside our scene. And then we also have the texture map input so that we can then drag whatever we like into that, and then it will apply the correct colors to our vertexes, or rather vertices. I'm not going to go in too much into detail with it right now, but Side Effects does have some good videos on setting all of this up and creating menus that are easy to use and to read inside Unreal. So the Houdini Foundations course is quite good for that. So this is our final result. I think it's simple, but it's effective in demonstrating what Houdini can do for you. Once the tool was set up, all of these assets, I think over 50 of them, as I said, will run through in less than 2-3 minutes. So it really is a huge time saver in creating your assets. The shapes and colors are accurate, and we also have full control over form and density of these sorts of things. As I said, it's a very short computation time. I would say less than 15 seconds for smaller meshes and around 30 seconds for larger meshes. And this actually brings up quite a good point that I would like to address for the sake of this. In terms of using UE5, I thought this was quite a good opportunity to test out nanite with something that wasn't, rocks and the like. So the Lego meshes are fairly dense. I think for the larger terrain meshes, it was something like 50 million tries, which is definitely high, but I think it's an ideal use case for nanite because lots of geometry, instance meshes, it makes for quite good performance. I don't think I had any issues on that front. So, in summary, you've taken your first steps into Houdini. Congrats, you're one of us now. You can never get out, no matter how hard you try. But yeah, on a serious note, I think that Houdini is definitely something that should be tried by more artists. I think, and myself included, I had a preconception that Houdini was for the tech gods among us, and that all of us lowly artists should not get into that territory. But seriously, it really has made my life easier with personal work and professional work, and it really does speed up those tedious processes and workflows, and really makes the output quite a bit more fun. Um, Whether you said, as Alice said in her talk before this, whether you're a prop artist, environment artist, character artist, I think it's really important to delve into the tech side a little bit. It's going to make you a much more well-rounded artist. And as I say over here, the freedom of expression really allows you to create anything that you would like to do, and there's infinite possibilities. Just before I go, these are a couple of YouTube channels that I used when learning Houdini, just to a very basic level, and they are really good and really free. So there's the Houdini YouTube channel, which actually a surprise for a software YouTube channel is really good, and the tutorials that they post are really good. There's Simon Verstraete, also known as Simon Houdini on YouTube, and his tutorials are, basically the pinnacle of what I'd expect from Houdini. And Nine Betweens Houdini Isn't Scary tutorial series is also a really good one. So that's me done. I hope that this has demystified Houdini a little bit and helped you maybe create an interest in wanting to try it. And so I thank you for your time and your attention.
Thank
questions?
you so much. Sorry. Thank you so much for that talk, Cairo. We have around 20 minutes of questions, so if people have any questions, feel free to pop them down in the QA channel, and Cairo, feel free to read them and answer those.
Sure. Okay, cool. Yeah, I will take a look at that and just read through the questions. So, don't really know much about Houdini, but you mentioned that for this workflow, you turned your model into points. My question might not make much sense, but how do you go on determining something like that, or the kinds of geometry needed for different workflows? Um, I would say that this workflow is quite specific to the output that I wanted to have. In this case, I knew that I wanted to create something like Lego, which is very ordered and structured and grid-like. And so that's why my first thought went to using, a volume from geometry, which creates that sort of grid-like thing. So it really depends on the result that you're trying to achieve. I would say, if you're trying to create modular pieces which are based on curves or something like that, then your approach is obviously going to be very different. Um, I would say that one of the big starting hurdles with Houdini is that there's a lot of nodes. So I've probably covered, not even, I don't know, 2 or 3% of them over here. So it really is quite a lot to deal with. But you eventually you get to the point where you know what sort of nodes are going to be good for your specific use case. Kim asks, how often do I use Houdini? Is it something that I default to when given a task? I would say at least once a month, maybe. It sort of depends because with Houdini, there is that initial setup time. So if you want to create a tool with it, then you do need to go through that sort of testing phase and setting everything up so that it is as robust as possible and that it can be used in a wide variety of situations. So it depends on the task as well. If I get tasked with a unique asset, it's a pot plant, for example. Let's like I know that potentially there's never going to be a need for 100 pot plants, so you sort of have to assess it on a case by case basis and see, would Houdini be a good use case for this? Can I automate a larger process with this? So Emil asks, now you blur the color of the bricks. Would it be possible to get each brick to pick the closest color from a color palette? Yes, that is possible. However, it's a little bit more involved because I don't want to get too much into the weeds for this presentation. So what you can actually do, and I was looking into, was you can there's an actual official Lego color palette, and it lists all the different colors that Legos do use and have ever used. So I was looking at inputting that into Houdini and making the Legos, sort of get the closest color as you suggested. So that is something, a little bit more involved, as I said, but I think it's worth looking at down the line. How easy is it to implement Houdini into an already existing pipeline? Hmm. I would say it depends. Um, as I mentioned in the talk, some people, like Cloud Imperium, for example, we have a lot of modular stuff, lots of sci-fi stuff, and lots of that stuff is based off trims and very repeatable workflows. So if you have a sort of project that has those sort of needs, I would say that Houdini can be implemented over there. It is just a case of looking back at what's already been created and what still needs to be created. And I would say that the ratio of those two might play a factor because if you're already 90% of the way through production and you've only got 10% of assets left to do, it might not be worth it to do that. But in terms of how easy is it, I would say it really depends on the studio. It depends on how quickly your artists are going to pick it up. It depends on the use case, as I said. Another question, to someone who's looking to get into procedural workflows, what would you say are the advantages of using Houdini over other procedural tools like Blender GeoNodes, for example? Um, so I know that similar results, such as the Lego generator, can be made through um, stuff like Blender GeoNodes. I haven't touched on it myself too much, but I'm not too sure as to the in-engine integration of it as much. So I couldn't speak on, how easy it would be to get that into, a proprietary engine, for example. So in terms of procedural tech, I would say Houdini's like integration is really nice, even though if it does take a while to set up. If we're talking other procedural tools, Substance Designer, stuff like that, they all have their pros and cons. I would say the pros are automation, batching, just like sheer volume of stuff. Whereas doing stuff by hand can get you a little bit more of, like a nice, if we're going hand painted, you can get really nice, hand done effects, and it's very personal to the artist, which you can't do very easily through proceduralism. So, like I said, there are pros and cons. Um, Hanla asks, are we able to use Houdini Apprentice with Houdini Engine in Unreal? I was under the impression you need a student or indie license to have access to HDA's exporting. That is correct. So Houdini Engine can be installed with Unreal at any point, so that you can import HDAs. There's no license needed there, or rather, there is a license, but it is free. Houdini Apprentice is also free. It is just needed for the session to be started for some reason. It was a sticking point that I found interesting. Um, However, you are correct in saying that you do need an indie license or above to export HDAs. So I believe that's one of the few functionalities locked behind a paywall for Houdini. Mike asks, could you technically use Houdini for real-time characters, or is it limited to more static stuff like environment? If yes, have you ever seen it used on a character, and in what way? I I've not seen it used for the actual creation of characters. I've seen it used for texture generation. I've seen it used for masks. This was probably a year or two ago on a different project. Um, so in terms of like the high poly sculpting or low poly making, unwrapping, not super useful as apart from maybe a first pass, but in terms of making like wet maps, grunge maps, and stuff like that for sort of contextual dirt, it's really good because the mask by feature node would actually be really cool for that, wetness being applied to character shoulders and head and stuff like that first. Um, so yeah, I would say not so much for the actual creation, but maybe some technical stuff after. It can. I've not dived too much into this myself, but I would say Retopo seems like it could be a good starting point. Or I know that animation requires like very specific topology for that, so I would have to look into that. Kai asks, thanks again to Kai for his help with all the coding stuff. Just wanted to give him a little shout out. Am I wanting to become a tech artist at some point, or do you rather want to stay an environment artist? Can you elaborate why you choose one over the other? Um, it's an interesting one, and I think that in the games industry, it's sort of it depends from studio to studio. Like I'm gonna say it depends so much during these questions, but it really does. Things change so often from role to role and title to title. But my current role, I think there are the opportunities for like some of like the technical stuff, and I do enjoy that. Um, I think on the whole, though, I think I would rather prefer to stay in a more environment art focused role because I don't know if I could just sit in Houdini all day and make tools and not use them. So I think the end use of the tool is rather rewarding when you get to see what you made work. Alice says, thank you for the talk. How did you find it going from art to a more technical side? And on a personal level, which do you enjoy more, tech or hands-on unique asset art? It's sort of similar to Kai's. I've always been interested in the tech side of things. Like, I would say that probably Designer was the first. I mentioned Designer maybe 10 times during this talk, but it really is one of my favorite softwares, and I do enjoy using it. And I think that's because of the procedural nature of it. I think my mind is sort of hardwired that way. I'm not. I would say I'm not nearly as creative as I am, more on the technical side of things. That's just how my brain works. In terms of tech and like or hands-on unique asset art, I will always try and speed up that workflow because I don't particularly enjoy the unique side of things. For me, the time invested versus what you get out of it isn't always as I would like it to be. So I would say, for me, the larger general picture is what I try to focus on. So, if I can find something to speed that up along the way, then great. Um, I've heard people say that Houdini isn't really needed, but that it's definitely a plus. Do you think that will change? You mentioned smaller studios starting to use it more, so maybe it's something that will be more important going forward. I can't say for the future for sure, to be honest, but I would say that it's definitely a plus. There's never going to be a negative to knowing another software that can benefit you in your career. I would sort of liken it to photogrammetry, although I'm not the expert on that subject either. I would say that, right now in lots of job applications I've seen over the years, photogrammetry is one of those that's listed as a plus, but not a requisite, a prerequisite. So I think it's that general direction. I don't know if it will ever become a must-have like a Max or a texture software. And I will say I don't know if it's even listed in most job postings these days. I don't think Houdini is that much on the map for environment art purely as well, and that also may be a factor that the environment art roles and technical art roles are a bit more distinct now. So um, in terms of tech art, I would say it's definitely weighing more on the side of it will change to be becoming needed. Environment art, I think we'll see. Mao asks, do you need a full grasp upon scripting to create HDA? How much scripting skill is needed for a starter to begin to use Houdini fluently to create modular assets for games? I would say next to none. I have very, very little coding knowledge. I have enough that I can look at code and understand what it's doing, but not enough to write it myself. So I've definitely not, you know, delved into that at all. So I would say next to none how much scripting skill is needed for a starter. The tutorials that I mentioned at the end of the talk, especially if Simon Verstraete or Simon Houdini on YouTube, he has like a great like sci-fi buildings course, how to create buildings from primitives, similar to the Ascent talk that I showed, and very little of that is using vast amounts of scripting, so I wouldn't let that hold you back. John asks, where do you find work out the expressions that you type into some of the nodes? Is there a cheat sheet? Is it more trial and error? A little bit of both. Like I said, I got Kai to help me with some of the expressions for the point groups and stuff like that. So that was definitely a little bit of trial and error to work out, what needed to go where. And even with simple V expressions like setting the mask to a certain size or to isolate at a certain size, that's something that you just need to play around with. I will say that the Houdini forums are very helpful, especially on the code side of things, if you're looking to get into that and to, just find libraries and stuff like that that will help with that. Alexander asks, when using a tool in Engine, are you at all worried about creating too many individual assets because it's so easy to do, especially if there's a whole team using the tool? That's a good question. I think the tool wouldn't have been made without the need for the tool, if that makes sense. So you're not going to make a Houdini tool if you if you only need a certain amount of assets. It's only if you really are getting into the higher end of things. Scope and that sort of creep is definitely easy to do when stuff like this becomes simple and easy. So I think, as you said, if it's the whole team using the tool, that's probably a case of, getting up to, that's probably TechArt's job to handle, how many objects in scene and poly count and all of that sort of thing. I just make the art. I don't have to worry about optimizing it. But yeah, I would assume that there needs to be some systems in place so that people don't go wild. And then last question from Alexei. Does Houdini Engine, is that optimized to use it in real time in Unreal? I mean some real time calculations. Um, if you're talking about like simulation stuff like water and destruction and stuff like that, I don't believe so. You sort of have to do some pre-calculations that are like cooked inside Houdini. In terms of the tool that I created, that's definitely the tool itself is definitely optimized enough to use inside Unreal. As I said, it was, less than 2 minutes to create or convert 50 plus assets. So I think on that side of things, it's really good. And there are some optimizations that you can do in Houdini. There are some calculations that are more expensive and time consuming than others. So you can also optimize your tools as well to be quicker. Yeah, I think that was the last one.
My Discord just crashed 20 seconds ago, so sorry for everyone who was watching on Twitch. But thank you so much for answering all those questions, Cairo, and that great talk. We have 5 minutes before the next speaker starts, so if anyone has to do anything real quick, 5 minute break, and then we can start with the next talk. Thank you so much, Cairo, and thank you everyone for coming.
Yeah, thanks for having me. Have a good evening.